Good morning, students. Welcome back to Max class. Today we are going to start chapter 9 Applications of Integration. Integration we have already studied in your 11th standard, that formulas and all, right? So take your page number 91. They gave integral formulas and all. Go through all the formulas. This year we are going to see applications of integration. Only last year only we saw the formulas. So this year we are going to see where we can use this integration. Okay, and this actually integration is one of the earliest subject. It is well known and it is very useful in our day-to-day life. And your first two exercise was not there, so directly we can go with exercise 9.3, and this 9.3 is only basic formulas we are going to use, right? So take your page number 98. Now take your heading as chapter 9 applications of integration. In that, first we are going to see integral calculus and their applications. Okay, so integral calculus we have two fundamental theorem, that is first fundamental theorem of integral calculus, second fundamental theorem of integral calculus. Okay, what is integral calculus? That is that we are going to use integration in calculus is your integral calculus, right? Okay, what is the first fundamental theorem of integral calculus? Look at your book, page number 98. If small f of x be a continuous function defined on the closed interval a comma b. So f of x is a continuous function. We are taking one continuous function on the closed interval a comma b, and that capital F of x equal to integral a to x f of u du. So if you are having taking another integral function f of x as integral f of u du, then your capital, that is differentiation of capital F of x, is your small f of x. So how we can say in a simple manner, look at here, capital F of x is an antiderivative of small f of x. This is your first fundamental theorem of integral calculus. What is that? What does mean by antiderivative? Antiderivative means integral. So f of x is the integral of small f of x, or you can say capital F of x is an antiderivative of small f of x. This is your first fundamental theorem. Now, second fundamental theorem, again same f of x or one continuous function we are taking in a closed interval. So, f of x be a continuous function defined on the closed interval a comma b, and capital F of x is an antiderivative of f of x. So, what we are taking, one capital F of x and one small f of x. Okay. So, how we can say the second fundamental theorem is integral a to b small f of x dx. What is this capital F of x? Is an antiderivative. So we can able to write this more integral of f of x dx equal to, using the antiderivative of f of x, upper upper limit minus lower limit. So in the function f, we can take f of b minus f of a. That is your second fundamental theorem of integral calculus. So integral a to b f of x dx equal to f of b minus f of a. And also we can see some property here. Using this property we can do the problems. Okay, this property will make you to do the problem easy. So in that, what is your first property is integral a to b f of x dx equal to. Okay, now look at here. What is your first property is, if you want to change the limit, what is the limit here? A to b. So if you want to change the limit in any case, what you have to do is, we can write this as minus integral b to a f of x dx. Okay, so if you want to change the limit, you have to put minus. That's all. That is your first property. What is the first property? If you want to change the interval, you have to take minus outside. Now, second property, integral a to b f of x dx equal to integral a to b. This f of x can be taken as f of adding the limits. So adding the limit is a plus b. So f of a plus b subtract with this function. So minus x. This is your second property. So integral f of x dx can be taken as integral a to b f of a plus b, adding a limit a plus b minus x into dx. This is your second property, and the remaining property is there in your page number 99. That also you can just go through that one. Actually, the remaining property we are not using in the problem. Next property, integral 0 to 2a f of x dx. So what is integral here? 0 to a 2a f of x dx. How can you split this one? See, integral, the 0 to a we can write it as 0 to a into f of x plus f of 2a minus x into dx. Okay, so how can you split this interval 0 to 2a? 0 to 2a, and this function will change into f of x plus f of 2a minus x dx. Next property, integral. Okay, if f of x is this, we have odd and even function. Okay, so if f of x is an even function, so if f of x is an even function, then integral minus a to plus a, integral minus a to plus a f of x dx. How can you write this? 2 into integral 0 to a f of x dx. Like this you can change. Okay, so if f of x is an even function, this minus a to a, how will you change? 2 into integral 0 to a f of x dx. Next property. Okay, even function we saw. What is the next one? Odd function. So if f of x is an odd function, okay, odd function, same integral minus a to a f of x dx will become 0. So simple thing, just see the question. If the function is odd function, directly you can give the answer as 0. If it is even function, that you can change the integral as minus a to a as 2 into integral 0 to a. Next property, integral minus a to a f of x dx equal to minus a to 0. Okay, this minus a to a we can split as minus a to 0 f of x dx plus integral 0 to a. We end up with 0, no? So that you have to start up with 0. 0 to a f of x dx. Okay, so this minus a to a, how can you split? Minus a to 0 plus 0 to a. Next property. If f of 2a minus x equal to f of x. If this condition satisfies, what is the condition? If f of 2a minus x equal to f of x, then this integral 0 to 2a f of x dx equal to, how can you write this one? This 2 you can bring here, 2 integral 0 to a f of x dx. Now what is this property? F of 2a minus x equal to f of x. If this condition satisfied, then you can write this 0 to 2a f of x dx as 2 into integral 0 to a f of x dx. Next property. Same thing if f of 2a minus x equal to minus f of x. Here it is plus f of x, this is minus f of x. Then the same integral 0 to 2a f of x dx equal to 0. You will get the answer as 0. Next property. Next one. Integral 0 to a. Okay, what is the integral? 0 to a x into f of x dx. X into f of x, that is, this is a product function, right? X is one function, f of x one function. So product rule we can use. That is 0 to a x into f of x dx can be taken as a by 2 integral 0 to a f of x dx. When you can take this one? If f of a minus x equal to f of x. If this condition satisfied, then you can write this x f of x as a by 2 integral f of x into dx. Now we can get into the exercise. This exercise only we are going to use a property and basic formula. For basic formula you can refer the table. Okay, now exercise 9.3, first question. Evaluate the following definite integral. So integral will be given, we have to evaluate. First subdivision is your homework. First subdivision, what formula we can use? Integral dx by x square minus a square. X square minus a square, we have the formula. Okay, so just refer the table and give the answer. Now take your second subdivision. Integral minus 1 to 1 dx by x square plus 2x plus 5. This is your question. Dx by integral x square plus 2x plus 5 is your question. We have to evaluate this. Okay, now tell me, can we use the direct formula? We can't use the direct formula because denominator, look at this denominator. Denominator is a quadratic equation. Quadratic equation, we don't have formula. So first you have to convert this into a factor. Okay, so we can use the completing the square format. Have you all remembered how to do the completing the square format? Yes, have to do, you have to take the variable as it is, sign as it is, and coefficient of x should be divided by 2. Okay, so I can write here. Now this question we can write it this as integral minus 1 to 1 dx divided by, so completing the square, what we have to do? We have to take the this one, x variable plus a coefficient of x should be divided by 2. So 2 divide 2 is 1. X plus 1 the whole square. Whatever number you are taking here, that you have to square and subtract. So minus 1 and the remaining number is plus 5. Again, if you write this one, integral minus 1 to 1 dx by x plus 1 the whole square minus 1 plus 5 is plus 4. Now what you got? Dx by integral, again integral minus 1 by 1 dx by x plus 1 the whole square. This 4 can be taken as 2 square. Now tell me what formula we can use. So dx by x square plus a square. Now refer the table and tell me what is the formula. Dx by x square plus a square. Yes, formula is 1 by 2 of tan inverse of x by a is the formula. Okay, now since we know the answer, we can evaluate this one. So if I evaluate this one, I can get dx by, for your reference I'll write the formula, integral dx by x square plus a square formula is 1 by 2 integral tan inverse of x by a. This is the formula. Now evaluate. Okay, this can be taken as integral minus, sorry, not integral. Integrating, we should not put this symbol. Okay, so bracket. This can be taken as 1 by 2 of tan inverse of x value is x plus 1 the whole square. So x plus 1, a value is 2. Tan inverse of x plus 1 by 2 into, what is the interval given? Minus 1 to 1. That you can take. Minus 1 to 1. Next what we have to do? You have to apply the limit. First upper limit minus lower limit. Correct? So first we have to apply the upper limit. Then you have to do the lower limit. Okay. Now we can evaluate 1 by 2. This will become, you can take a whole bracket. Okay. Tan inverse of, you have to substitute instead of x 1. So 1 plus 1 by 2. Correct? Minus, lower limit, you have to take it as minus. So minus tan inverse of, lower limit is what? Minus 1. Minus 1 plus 1 by 2. That's all. Here no need to put that minus 1 to 1 because we evaluated no. Next, which is equal to 1 by 2 tan inverse of 1 plus 1 2. 2 cancel item. So you will get answer as 1 minus, this is tan 0. Tan inverse of 0. Now, when you will get the value as 1? When it is pi by 4. So, this will become 1 by 2 of pi by 4 minus 0. That is, if we multiply this 2, we will get pi by 8. So, pi by 8 is your final answer. Is that clear? So, just we are evaluating. That's all. Now, third subdivision. Question, integral 0 to 1 square root of 1 minus x by 1 plus x dx. Now tell me, can you apply the formula directly? No, because we have a numerator function and denominator also you have function. Okay, so we have to do some other method only. So here we can write it as integral 0 to 1. Okay, we have to multiply by its conjugate. 1 plus x. What is its conjugate? 1 plus x now conjugate is 1 minus x. Multiplying by its conjugate you will get 1 minus x into 1 minus x divided by 1 plus x into 1 minus 8 square root into dx. Correct? Okay. 1 minus x the whole square. So whole square and square root will get cancelled. This will become 0 to 1. 1 minus x and denominator a plus b into a minus b. What is the formula? A square minus b square. So root of 1 minus x square. Now we can split this 1 by this one, x by this one. We can split the function. Okay. Again we can write it this as integral 0 to 1 1 by root of 1 minus x square plus integral 0 to 1 this minus x by square root of 1 minus x square into dx. Okay, we are just splitting the function. Now, okay, this one, can we directly apply the formula? 1 by root of 1 minus x square. What is formula? Sine inverse x. Very good. So this you can write it sine inverse x and interval is 0 to 1. Here directly we can't use the formula because the numerator we have x is there, minus x is there. So what we can do is multiply and divide by 2. So this you can write it as plus 1 by 2 integral 0 to 1 of minus 2x by square root of 1 minus x square into dx. Now look at here. We can use, see, square root integral 1 by root of 1 minus x square. X square differentiate panna minus 2x we are getting. Okay. So this is a chain rule, but you can use a formula 1 by square root of 1 minus x square. What is the formula? Sine inverse. That you can differentiate this one. Okay. First we can simplify this one. Sine inverse x limit is 0 to 1. So upper limit minus lower limit. Correct? Now you can write it this as sine inverse 1 minus sine inverse 0. We completed this one plus this one 1 by 2 integral 0 to 1. You can write this 1 minus square root of 1 minus x square as 1 minus x square whole power 1 by 2 and into minus 2x dx. We are using chain rule here. Okay, now which is equal to sine inverse 1. When you will get sine value as 1 pi by 2. Next sine 0 0 only. So minus 0. Okay, plus 1 by 2. Now this one x power n. What is integral x power n formula? Into x power n plus 1 by n plus 1. Correct? So this you can write it as 1 minus x square whole power 1 minus 1 by 2 plus 1 by 1 minus x square, sorry, minus 1 by 2 plus 1 plus 1. Again, if you simplify, pi by 2 plus 1 by 2 of 1 minus x square minus 1 by 2 plus 1 is half. Similarly, denominator is also half and the interval is 0 to 1. Correct? Now we have to apply the interval. Upper limit. Upper limit is 1. So if I substitute 1 here, 1 minus 1, 0. So the whole thing will become 0. Now if I apply lower limit, now I have to put minus 0. If we apply 1 minus 0 is 1. This 1 by 2, this 1 by 2 will get cancelled. So the remaining will be 1. Your final answer will be pi by 2 minus 1. That is your final answer. Next, fourth subdivision, integral 0 to pi by 2 e power x into 1 plus sin x divided by 1 plus cos x into dx. Okay. So how can we do this one? Which is equal to integral 0 to pi by 2 e power x. We can split this function 1 by denominator, sin x by denominator. Okay, so if I split like that, how will you write? 1 by 1 plus cos x plus sin x by 1 plus cos x into dx. Now, what is 1 plus cos x? Now we have to use the trigonometry formula. What is 1 plus cos x? 1 plus cos, this is a half angle formula. So 1 plus cos x is 1 by 2 cos square x by 2. This is a formula. Okay, so here we can write 1 by, instead of 1 plus cos x, we are having the formula 2 cos square x by 2, half angle formula, plus this is also half angle. What is sin x formula? 2 sin x by 2 cos x by 2. Denominator same thing, 2 cos square x by 2 into dx, which is equal to integral 0 to pi by 2 e power x. This we can take it as, and this cos, 1 cos and square will get cancelled, 2 will get cancelled. So sin by cos is tan, correct? And this one 1 by cos secant. So here we can write it this as secant square x by 2. This 2 will remain as it is 2 plus sin by cos is tan. So tan x by 2 into dx, which is equal to, now we have a formula that, okay, this is a formula, integral e power x f of x plus f dash of x into dx equal to e power x into f of x. So with e power x, if you have the form f of x plus f dash of x, then you can give the answer as e power x into f of x. Now look at this one. What is tan x differentiation? Secant square. Correct? So tan x by 2 differentiation is secant square x by 2 by 2. So this is f of x. If I take, I will get f dash of x. So now for this, after this step, I can use this formula, which is equal to e power x into f of x means tan. So e power x into tan x by 2, and the limit will be 0 to pi by 2. Next, that's it. We have to apply the limit. So e power pi by 2 tan pi by 4 minus 0, which is equal to e power, tan pi by 4 is 1. So e power pi by 2. E power pi by 2 is your final answer. Next, fifth subdivision. Integral 0 to pi by 2 square root of cos theta into sin cube theta d theta. Solution. Okay, here we are going to use substitution method. So whatever is given, that we are going to take it as I. I equal to integral 0 to pi by 2 square root of cos theta into sin cube theta d theta. This we can write it as integral 0 to pi by 2 square root of cos theta. In the cube, we are splitting as sin square theta into sin theta. Okay. Now, which is equal to integral 0 to pi by 2, this one, square root of cos theta. The cosine square, we can write it as 1 minus cos square theta again into sin theta d theta. Now we are using substitution method. Let us take t equal to cos theta. So if I differentiate this one, I will get dt equal to minus sin theta into d theta. Okay, if we use substitution method, definitely that limit value will also change. Correct? Okay, so when, what is the lower limit? 0. So when theta equal to 0, we have to substitute 0 here. Cos 0 is 1, correct? So when theta equal to 0, na, t value equal to 1. Next, what is their upper limit? Pi by 2. When theta equal to pi by 2, na, cos pi by 2 is 0. So t equal to 0. Therefore, we can change the I as I is equal to integral limit will change, correct? So what limit? 1 to 0, okay, square root of t, because we are taking t equal to cos theta, no? So square root of t into 1 minus t square minus dt. How can you write this one? Integral 0 to 1 square root of t. This minus we can take outside, okay? So square root of t 1 minus t square into dt. Okay, I have taken this outside minus. Now, to remove the minus, I can change the limit. We saw the property, no? So to remove the minus, we can change the limit. That is, this will change integral 1. Okay, 1 to, actually this is also 1 to 0. This here only, it will change as 0 to 1. So integral 0 to 1 square root of t 1 minus t square into dt. Here we are using property. This is equal to, now we can multiply inside, okay? So integral 0 to 1, 1 into root t is root t, that we can take it as t power 1 by 2 minus t power 5 by 2. 1 by 2 plus 2 is 5 by 2 into dt. Now what is x power n integral? X power n plus 1 by n plus 1, right? This we can take it as t power 1 by 2 plus 1 is 3 by 2. 3 by 2 by 3 by 2 minus t power 7 by 2 by 7 by 2. Limit is 0 to 1. So if I substitute limit as 1, this will become 1 power anything is 1 only. Taking this to the numerator, you will get 2 by 3 minus 1. So this when goes to numerator, it will become 2 by 7. 0 substitute panna, all will get 0. So 2 by 3 minus 2 by 7. We have to take LCM. So 21. 7 2s are 14 minus 3 2s are 6, which is equal to 8 by 21. 8 by 21 is your final answer. So today's, that's all. And your homework is first problem, first subdivision and sixth subdivision. Thank you, students.